Hello, I'm Diego Navarro from the STIM on the Gastric Nutrition Laboratory at the University of Illinois, and I will be discussing the effects of inclusion rate of high fiber dietary ingredients on apparent ileal, hindgut, and total tract digestibility of dry matter and nutrients in mixed diets fed to growing pigs. Diet costs account for approximately 70% of production costs, and feeding a traditional corn and soybean meal diet is becoming expensive. Therefore, a more complex diet is often fed to take advantage of less expensive feed ingredients. Examples of these are high fiber co products such as corn DDGS, sugar beet pulp, and wheat middlings, which are all readily available for use in swine diets. However, pigs lack digestive enzymes capable of digesting dietary fiber, and as a consequence, dietary fiber must be fermented by the microbes in the intestinal tract of the pig to obtain energy from it. A consequence of feeding high fiber diets is that this may result in reduced growth performance in pigs. The reason behind this negative effect may be due to the reduction in digestibility of nutrients such as crude protein, fat, and minerals, as well as a dilution of the energy content of the diet. The pig may not be able to meet its energy requirement if this fiber effect is not taken into consideration in diet formulation. Another possible reason is fiber's potential effect on the physical characteristics of digesta, which may alter the mixing, diffusion, and rate of passage of nutrients along the intestinal tract. Because pigs lack enzymes to digest dietary fiber, it is typically not well utilized by the animal, and instead has to be fermented by microbes inhabiting the intestinal tract. Soluble dietary fiber is easily fermented to synthesize short chain fatty acids that contribute to the energy status of the animal. On the other hand, fermentation of insoluble dietary fiber is hypothetically very limited. However, recent studies have shown relatively high digestibilities of insoluble dietary fiber in diets containing elevated concentrations of high fiber ingredients. Previous results indicated no difference in the calculated digestible and metabolizable energy values in high fiber ingredients measured at 15 and 30% inclusion rates. And so the objective of this experiment was to determine if values for apparent ileal digestibility, apparent hindgut disappearance, and apparent total tract digestibility of dry matter and nutrients measured at 15% are also accurate if measured at 30% inclusion rate. A second objective is to determine the location and extent of fiber fermentation in growing pigs, and to verify previously reported values for digestibility of insoluble dietary fiber. The four high fiber ingredients used include canola meal, corn germ meal, sugar beet pulp, and wheat middlings. 20 ileal cannulated barrels with initial body weight of around 31 kilos were housed in metabolic crates and allotted into a replicated 10 by 4 incomplete Latin square design with 10 diets and 4 26-day periods. This gives us 2 pigs per diet per period with a total of 8 replicate pigs per diet. Each 26-day period consisted of 14 days of adaptation to the experimental diets. This was followed by 5 days of urine and fecal collection, and then a 2-day ileal collection on days 22 and 23. The experimental diets included a corn and soybean meal basal diet and a corn soybean meal 30% cornstarch diet. 6 additional diets were formulated to replace 15 or 30% cornstarch with 15 or 30% corn germ meal, sugar beet pulp, or wheat middlings. An additional 2 diets were formulated by including 15 or 30% canola meal in a diet containing corn, soybean meal, 30% cornstarch at the expense of corn and soybean meal. Cornstarch was used so that added fiber was supplied by the test ingredient alone. Dry matter digestibility in the corn soybean meal diet was determined, and the contribution of corn and soybean meal to the dry matter digestibility in all other diets was calculated. And by difference, the dry matter digestibility in cornstarch was calculated, and the contribution of cornstarch to dry matter digestibility of test diets containing cornstarch was determined. By calculating the contribution of both cornstarch and corn and soybean meal to the test diets, dry matter digestibility of test ingredients was calculated by difference. This was only true for dry matter and organic matter digestibility because cornstarch does not contribute any other nutrient to the test diets. The effects of adding 15 or 30% of each high-fiber ingredient to the corn, soybean meal, cornstarch basal diets were analyzed using orthogonal contrasts. Independent sample t-tests were conducted using the t-test procedure to compare response variables between 15 and 30% inclusion rates within each ingredient. Moving on to the results. On the diet level, there was a linear reduction in the apparent ileal digestibility of dry matter with the addition of 15 or 30% of test ingredient compared with the cornstarch diet. And the same trend was observed for the apparent ileal digestibility of organic matter and crude protein, as well as the apparent total tract digestibility of dry matter, organic matter, and crude protein. In contrast, the apparent hindgut disappearance of dry matter in diets linearly increased with the addition of test ingredients compared with the cornstarch diet, and this may be due to the increased dry matter flow into the large intestine. Looking at digestibility of fiber, there was a linear reduction in the apparent ileal digestibility of insoluble dietary fiber with the addition of canola meal only. I would also like to point out the apparent ileal digestibility of insoluble dietary fiber was observed to be as high as 35% in the diet containing 30% wheat middlings. There was a linear reduction in the apparent total tract digestibility of insoluble dietary fiber in diets containing canola meal or wheat middlings, but a linear increase in diets containing sugar beet pulp compared with the cornstarch diet as inclusion rate of test ingredients increased. Additionally, we observed relatively high digestibility values for insoluble dietary fiber, and this has been consistently reported in recent years. A possible explanation for this, although it is counterintuitive, is that a fraction of analyzed insoluble dietary fiber may be solubilized along the gastrointestinal tract of the pig. It may also be possible that this fraction is analyzed as soluble dietary fiber, which could explain the negative values for apparent ileal digestibility of soluble dietary fiber in diets. Solubilization of insoluble dietary fiber may not necessarily indicate that insoluble dietary fiber is digested and absorbed, but it suggests that the fiber structure may have been altered and subsequently analyzed as soluble dietary fiber. However, to our knowledge, this has never been reported and needs further investigation. It is also possible that current analytical methods may have influenced the results because they were developed to determine fiber in food and feedstuff and not in ileal digesta or feces. Moving on to the results on the ingredient level, the apparent ileal digestibility values for crude protein in canola meal was different between 15 and 30% inclusion rates in the diet. However, there were no significant differences between the apparent ileal digestibility of dry matter and other nutrients, as well as the apparent hindgut disappearance of dry matter and other nutrients in canola meal between inclusion rates, and the same trend was observed in all other test ingredients. We also observed that the apparent total tract digestibility of dry matter and organic matter was different between 15 and 30% inclusion rate of corn germ meal and wheat middlings in the diet, but this was not the case in canola meal or sugar beet pulp or for other nutrients. In conclusion, inclusion rate of high-fiber dietary ingredients did not affect the apparent ileal digestibility, apparent hindgut disappearance, or the apparent total tract digestibility of most nutrients in the ingredients. There are also relatively high digestibility values for insoluble dietary fiber in mixed diets observed in this experiment. So what I want you to take away from this presentation is that although there is degradation of some fiber fractions before the end of the small intestine, the majority of fermentation takes place in the hindgut. And due to the high digestibility of fiber observed in this experiment, as well as in other recently published data, digestibility of fiber may have traditionally been underestimated. I would like to thank AgriFirm Innovation Center of the Royal Dutch AgriFirm for financial support of this project. And if you would like to know more about fiber nutrition or swine nutrition in general, I encourage you to visit our website at nutrition.ansi.illinois.edu. Thank you.